So it is very important to choose right liquid stationary phase. This table shows you the commonly used stationary phase in capillary gas chromatography. Okay, let's look at this one. The first one is diphenyl dimethyl polysiloxane. Yeah, this is very commonly used stationary phase, and depending on this x value, okay, x value, the polarity changes. Okay, and usable temperature range also depends on this x1. Okay, when x is zero, this is zero. There is no this one. Okay, and it has only this part, and this is a non-polar, very strictly non-polar column. Okay, here first let's take a look at this remark. Choice the principle of choice of liquid stationary phase is the like dissolves like. The like means that this is general principle for this dissolution. Yeah? Like, yeah, so polar, the species mm, more readily dissolves in polar solvent. Okay, non-polar solute dissolves in non-polar solvent. Okay, yeah, that's in short, like dissolves like. Okay? And when X increases to 0.05, still non-polar, and temperature range quite wide, and X is 0.35, intermediate polarity it has. Okay, and at higher value of X, still intermediate polarity. Okay, because this part is more polar than this one, but never polar. Okay, and other stationary phase, which is this one. Okay, this is all intermediate. It gives all intermediate polarity. Okay, and the temperature range is quite wide. And this one, polyethyl uh, glycol. This one is for this one. This is carbowax. This is also widely used column. This is strongly polar because of this oxygen atom in the structure, and this is the temperature range. And this one is strongly also polar, and temperature range is here 0 to 275 degrees C. Okay, yeah. So non-polar columns are best for the non-polar solutes. Okay, this non-polar solutes are readily dissolved in non-polar columns, non-polar stationary phase to be separated. Intermediate polarity column is best for intermediate polarity solutes, and for polar column is for the best for strongly polar solutes. Okay, so when uh, the structure contains oxygen or quite electronegative elements, there is a high chance for polarity, polar characteristics. Okay, and what about the polarity of solute? Okay, saturated hydrocarbon. This one is strictly non-polar, and olefinic hydrocarbons are also non-polar, and aromatic hydrocarbons and halocarbons and mercaptans, sulfide, CS2, those are polar solutes. But weak intermediate polarity, yeah, these the groups of solute have weak intermediate polarity: ethers, ketones, aldehydes, esters, tertiary amines, nitro compound without alpha hydrogen atom, nitrates without alpha atoms. Okay, but there are strong uh, the compounds that show a strong intermediate polarity, for alcohols. Okay, carboxylic acid, they are strongly intermediate, not strongly polar. Phenols, primary and secondary amines, oximes, nitro compounds with alpha the hydrogen atoms, and nitriles with alpha hydrogen atoms. And also there are compounds that show strongly polar characteristic. Polyhydroxyalcohols, amino alcohols, hydroxy acid, polyprotic acid, polyphenols. Those are, you know, compounds of strong polarity. Okay? As a column ages, stationary phase picks up. Surface silanol groups are exposed and tailing increases. Okay, so this stationary phase, the stability is not eternal. Yeah? It has a kind of lifetime. Yeah? So if you use stationary phase over and over and over, and then eventually it will break down. Okay. Exposure to oxygen from air at high temperature also degrades the column. Okay, as I mentioned that the column may bleed. Okay? To reduce the tendency of stationary phase of bleed from the column at high temperature, it is usually bonded to silica surface or covalently cross-linked to itself. Yeah? A bleed means that it's detachment. Okay, and making chemical bond, covalently cross-linked bond on, or bonded to silica surface, may reduce this bleeding tendency. Okay, let's stop here.